b, we're doing the limit. So we approach 0 from the right of x, natural log of x. All right, if we just plug in, you end up with 0 times natural log. As it's approaching 0, it's going to negative infinity. 0 times infinity is one of our indeterminate forms. We don't know, is it getting to 0 faster, infinity faster, or something in between. Indeterminate forms require L'Hopital's, but we can't do L'Hopital's until it's written as a fraction. So our strategy was to rewrite this. We're not changing the problem, so it has to mathematically be equivalent, but so it's a fraction. And we did that by dividing by the reciprocal. If you divide by 1 over x, it's the same as flipping and multiplying by x. Now, if I plug that in, as you're approaching 0 from the right, the natural log of x, that's going to negative infinity. 1 over a smaller and smaller number is going to infinity. Infinity over infinity, that's when we can do L'Hopital's. So I did ask, we labeled it LH to show this is the step where we do L'Hopital's. L'Hopital's says you can do the derivative of the top, so the derivative of the natural log is 1 over x. You can do the derivative of the bottom. 1 over x, that's like x to the negative 1. So the derivative will be negative x to the negative 2. Remember, this is not a true derivative because we didn't do quotient rule. It's just the top and bottom separate. This means 1 over x and negative 1 over x squared. How do we divide fractions? X approaches 0 of negative x, and if we plug in our 0, then we get 0. So we had to do L'Hopital's so that we could get to the point where we could plug it in the value. Make sure you are fixing any of this. I'm going to collect those study guides tomorrow before we take our finals, so make sure you have all the correct answers on there at that point. Okay, so if I plug this in, right now it's 0 to the 0 power. That's an indeterminate form. We have to write it so we can do L'Hopital's. L'Hopital's requires us to have a fraction. The only way to get this to a fraction is to add a natural log. Remember, the reason we add natural log is the properties of the natural log. The exponent can come down in front. Now, if I add a natural log, what do I know I'm going to have to do at the end? I need to write this as a quotient because right now it's just 0 times negative infinity. That's still indeterminate form. So to get a fraction, we divide by the reciprocal. We could write that if we preferred. It's like x to the negative 1/2 power. Now if you plug in, this is infinity, 1 over the square root of a smaller and smaller number, that's also going to infinity, so it's infinity over infinity. So this is the step where we can do L'Hopital's. So the derivative of the natural log is 1 over x. Derivative of x to the negative 1/2 is negative 1/2 x to the negative 3/2. Clean up if you can. So this is negative 1 over 2x to the 3/2. If we want to divide fractions, we have to flip and multiply. So this is the limit, x approaches 0 of negative 2x to the 1/2. Now you can plug your 0 in, finally. Negative 2 times the square root of 0 is 0. My answer is e to the 0 power which is 1. So at the very end, you have to make sure you put that e back. Questions about L'Hopital's? Number 16. A function. And then I ask you a ton of information about this. So first step, domain. What can x not be here? So my domain is everything else. Negative infinity to 0. Union 0 to infinity. And then I asked for x and y intercepts. An x-intercept is when y is equal to 0. If you multiply everything by x squared, does anything multiply to 1 and add to 1? No. So if you try to do the quadratic formula, opposite of b plus or minus the square root of b squared, so 1 squared minus 4 times 1 times 1 over 2 times 1. What happens underneath the radical? We get 1 minus 4, which is negative. So that means this is imaginary. So what does that mean about my x-intercept? It's imaginary. There is none. Our graph is not going to touch the x-axis. To find a y-intercept, you plug in 0 for all of your x's. If I do that, I get 1 plus, and then it's undefined. So that means that can't happen. So no y-intercept either. Symmetry I should have taken off since we don't have our graphing calculators. I wouldn't make you check that. So asymptotes, vertical asymptote, x equals, what makes the bottom 0? Just 0. How do we find our horizontal asymptotes? So we're looking for our horizontal asymptote, and we had to do the limit as we approach positive and negative infinity. We said most of the time these are the same. It's when you have like radicals that you need to worry about them not being the same. If I do that, 1 over infinity goes to 0, so this whole thing goes to 1. So our horizontal is y equals 1. All right. So far, all we have is that this graph has a vertical asymptote at 0, horizontal asymptote of 1, and it never hits the x or y axis. Next thing I asked for is increasing, decreasing. So to do that, we have to do our derivative. Derivative of 1 is 0, derivative of 1 over x. You could think of that as like x to the negative 1. So it would be negative x to the negative 2 minus 2x to the negative 3, or maybe 1 over x squared minus 2 over x cubed. Okay, we need to find our critical points, so I'm looking for anywhere this is 0 or undefined. So if I set that equal to 0, so I'll get 2x squared plus x cubed, so I could take out x squared. So my critical points, anywhere it's 0, which happens at 0 and negative 2, or undefined, actually undefined is when it's equal to 0. Okay, so to find increasing and decreasing from that, we have to do our sign line. So smaller, in between, and bigger. If I put those in, if I put in a negative 3, I get a negative 1/9 plus 2 over 27, which gives us a negative. If I put in negative 1, I get negative 1 plus 2, which is positive. Put in a 1, negative 1 minus 2 is negative. So that means this graph is increasing from negative 2 to 0, decreasing from negative infinity to negative 2, and 0 to infinity. All right, make sure you are making corrections as needed. Any questions to that point? Then we need maxes and mins. So this went from decreasing to increasing, so that would be a min. We need the full ordered pair, so to get the y, you have to put negative 2 back into the original. So I get 1 minus 1/2 plus 1/4, so that gives me 3/4. But when I plug in 0, so 0 went from increasing, decreasing, so it should be a max, but what happens when you try to plug 0 in up here? You can't, so that means there isn't a local max, because that point is undefined. All right, then it asks for inflection points and concavity, so we need our second derivative. So go back to your first derivative. If we do the derivative of that, we get 2x to the negative 3 plus 6x to the negative 4. And 2 over x cubed plus 6 over x to the 4th. You guys with me? Hunter, are you making any corrections as you need to? All right, we need to find out anywhere this is 0 or undefined. You could solve it like I did the previous one, bring it over and cross multiply. You could also take out a GCF if you wanted. I'm going to do it that way just to show you two different ways of solving this one. You could take out like 2 over x to the 4th. So that would just leave you with an x in the first term. I think you're essentially dividing by a flip and multiply. And a 3 in the second term. Just another way of solving it. If you don't like that, you can solve it the way we did the first one. So our inflection points, anywhere this is 0 or undefined, we can see it's undefined if x is 0, because that puts 0 in the denominator, and negative 3 makes it equal 0. So then if we do our sign line, all right, if I put in a negative 4, I get negative 2 over 64 so that should be a negative. I put in a negative 1, negative 2 plus 6 is positive. If I put in 2, I get 1 over 4, and that's also positive. Okay, so my concavity is concave down from negative infinity to negative 3. I cannot say it's concave up from negative 3 to infinity, though. Why? So we'd have to go negative 3 to 0 and 0 to infinity, because we already have an asymptote at 0. All right, we mark our inflection points with x's on the graph. So if we put in a negative 3 to the original, I get 1 minus 1/3 plus 1/9. So 7/9. I'm going to adjust my graph a little bit. I'm going to make my y-axis. So here's my region. And negative 3, 7/9. Above that. So now we have to draw a graph. We know that our graph is decreasing until I get to this dot. It is concave down until I get to my x. So falling, but curving downward. We know asymptotes, we have to be approaching them. Then it's got to switch to curving upward. Okay, but still falling. After 2, it starts increasing until I get to 0. And so what's happening is it's increasing, it's curving upward. We know vertical asymptote, you're just getting closer to it, so it looks like that. And then we said it's decreasing after 0 and curved upward. So decreasing but curved would look like this. All right. Those types of questions, obviously worth a lot of points because there is a lot involved there. Any questions on that one? Okay. Let's take a look at our word problems then. So number 17, we have a farmer building a rectangular corral. We have a rectangle. Some of the fencing will be used to construct 2 inner divider fences, both parallel to the same sides of the corral. So I'm going to put 2 fences in here. What is the maximum possible area? So if I wanted to label these, I could call this x and this is y. We know area equals x times y, length times width. The problem is, to get the maximum, we have to do the derivative. Okay? The derivative of this requires a product rule. And I don't know how all those variables are related to one another. So I need to get it in terms of the same variable first. That's where the other piece of information comes in. We have 600 feet of fence. So if I label, my perimeter is 600. So that means 4x plus 2y equals 600. Correct anything that you need to on this. Make sure you have everything with the right answers to turn in tomorrow. So if we divide, y has to be 300 minus 2x. So for my area, x times y, which is 300 minus 2x, distribute. Then how do we find a maximum or a minimum? Derivative. So derivative would be 300 minus 4x, and we're looking for when the derivative is 0. So if you do that, you get x to be 75. We have to answer the question. The question asks, what is the area? So I'm going to plug my 75 in to my area formula. So the maximum area is 11,250 square feet. Is that one okay? All right, so problem 18. We have another one of these. So this time, we are talking about making a box. So it says we have a rectangular box with a square base. Okay, if the base is square, that means these are the same. I don't know my height. You can call it h, you can call it y, whatever you like. Then, we know that we are trying to find the greatest possible volume. Volume is length times width times height. So x times h, so x squared h. That's what we have to do the derivative of. Before we can do that derivative, we need to get it in terms of one variable. So we have to use the other piece of information, which is the cost. So the top and the sides each cost $1. So the dimensions of the top, length times width, x times x is x squared. And that costs us $1 to make. Okay, then if you go through the sides, this side is xh, this side is xh, this side is xh, this side is xh. So we have 4 of those. And how much do we pay for the sides? $1. And then we have the bottom. The area of the bottom, length times width, is x squared. That one costs us $2. And that is equal to our total cost of $144. So that means 3x squared plus 4xh equals $144. Let's solve for h. H would be 144 minus 3x squared over 4x. Plug that into our volume. And we can cancel 1x out. I'm just going to go ahead and break this part. So 144 divided by 4 is 36 times x minus 3/4 x squared times x is x cubed. Anytime I ask for a maximum or minimum, we have to do the derivative. squared. Set that equal to 0. So multiply by 4 and divide by 9, 16. Square root, we know x can't be negative because it's a length, so we get x to be 4. So the box is 4 feet by 4 feet. To find our height, we can plug it in right here. So that would be 6 feet. Any questions there? Then we jumped all the way to 23. So we're asked to find the sum from 1 to n of f of x sub I times the change in x for f of x equal x squared. Our interval is 0 to 2. And then we have to find the exact area from it. So first we have to find these pieces. All right, so we need our change in x. So n minus beginning divided by number of rectangles, so that's 2 over n. We need our x sub I, so that's our starting point plus the change in x times I, the number of times you've used it. So that's 2 over n of I. So we have the sum from 1 to n. F of x sub I, so if I plug this into my function, I get 2 over n I squared times the change in x, which is 2 over n. 8 over n cubed I squared. Okay, summation rules. That 8 over n cubed, you could just factor that out. Summation rules for I squared. That's n times n plus 1 times 2n plus 1 over 6. Remember, if you're adding up I, it's n times n plus 1 over 4. And so we've got those rules for each different power. We had I squared, and I cubed. All right, then we want to simplify this because ultimately we're going to do the limit as n is approaching infinity. So we need to multiply it out, look for some quick tricks. We can reduce that to 4/3. We can cancel on n. Or if I FOIL that out, 2n squared, cn plus 1 over 6n. No, 6n, that was 3n. Okay, so then if we break that apart, we have 8n squared over 3n squared, so that's 8/3. 12n over 3n squared, so 4 over n, plus 4 over 3n squared. A number over infinity goes to 0, so 8/3 plus 0 plus 0 just gives us 8/3.
I got the right answer, but my work's not right, but I'm not sure.
Okay. Left, right, and midpoint sums. F of x is x squared plus 2x. Interval 1 to 4. 6 rectangles. So we always had to find our change in x. So ending minus beginning divided by n. So 3 over n is 1/2. Okay, so all of these, the width of the rectangles, 1/2. length times width. So all of them have the same width, so you'll be taking all of them times a half. And then we just have to add up the 6 heights. So if you think about your left one, you're starting at 1. We're going to go up by 1/2. So 1.5 would be the next one. The left says you start with the leftmost point. So the first number I plug in would be my 1. And I'm plugging it into the function. So 1 squared plus 2 times 1. And then we go up a half. So the next number would be 1.5 squared plus 2 times 1.5. Sorry, that's sloppy. Hopefully you guys know what I'm saying there. Go up a half. So that's 2 squared plus 2 times 2. Next would be 2.5 squared plus 2 times 2.5. 3 squared plus 3 times 3.5. Plus 2 times 3. Right, and then 3.5 squared plus 2 times 3.5. Now, on the test, without a calculator, I would just have you set it up and leave it. Or I would have to give you really nice numbers to plug in. This turns out to be 30.875. The right-hand sum, we do the same way, but the first number we plug in is the right-hand endpoint. So I start with the 1.5. Still going up by a half each time. So next I plug in 2. Next I plug in 2.5. Three. 3.5. Last one, because I need 6 total, we would have to plug in 4. Remember, the only difference between these is the first and last point. And then if you do that one, it turns out to be 41.375. This could also be called over and under approximation. The first one is an under. This one is an over. The real answer is somewhere in between. So if we needed to get that real answer, or we need to be more precise, we know we could do more rectangles. We can also look at our midpoint sum, which is the final one here. So if we look at the midpoint, we are looking in the middle of these. So think about adding them up and dividing by 2, so 1.25. So that's the first number you plug in. Then we have to go up by 0.5. And keep adding our 0.5, so that's 2.25. 2.7. And that one should give us something between the others, which it does, 35.937. All right, that's everything you guys asked for. Do we have any others?